What do you know? We have made it to the last new material of the first unit. So this won't be the last lesson, but it's the last bit of new material. So let's jump in, get it over with, and then the new material will be behind us. So mainly today we're going to be talking about angle pairs. So we're going to identify and measure adjacent angles, vertical angles, complementary and supplementary angles. Or basically any kind of pair we're looking at. So let's look at the first set of definition. So adjacent angles, let's get my pen here. Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. So if we look at this picture, we have where they share this side right here. And they share this vertex. But notice they don't share interiors. We've got the top one. And then we've got this bottom one. Think of it like that bar in the middle is kind of like separating them. You stay on your side, I'll stay on mine. That's an adjacent angle. That's a pair of adjacent angles. So in this case, we can say, excuse me, angles 1 and angle 2 are only adjacent angles. So, yeah, they share a common vertex and a common side. A linear pair of angles is a pair of adjacent angles whose non-common sides are opposite rays. So if we look at this picture, what do you notice? They do share this side right here, but then what do their sides that they don't share do? They make a line. So for a linear pair, if you add the angles together, you should get 180 degrees because that's a line. So let's just put this in here. Angles 3 and 4 are adjacent angles. So now let's look at this first example. They ask us to tell whether the angles are only adjacent. So there's one option. Adjacent and form a linear pair. There's another option. Or not adjacent at all. There's our third option. So we got 3 different options to choose from. They're only adjacent, adjacent and linear, or not adjacent. So A, ask us about angles 5 and 6. So what I'm going to do is I'm going to highlight in different colors each of the angles, so then we can make our decision based on what's highlighted. And this would be a good strategy when you're doing your assignment or thinking forward to the future, even the test. This would be a good strategy. Kind of color in to see, oh, what do they do? So looking at these angles, this red and green, They're definitely adjacent because they share a side, but then what do their other two sides do that they don't share? They make a linear pair. So these, and we're going to abbreviate because I don't want to write out that whole thing. We're going to say adjacent and linear pair. So I guess I should have written our abbreviations that we're going to use up here. That's adjacent. The next one, we already used it. And then if it's this last option, we're going to say not adjacent. Okay. Now let's look at B. They ask us about 7 and 8. So let me erase this and grab our new angles. So 7 and 8. Do they share anything? Do they share a side? They share a vertex, but do they share a side? No, they don't share a side. So this one, we can say it is not adjacent. They have to share a side to be adjacent. And they don't. So not adjacent. C asks us about 7 and 5. So I'm going to erase 8 here. We still need our 7, but this time we need 5. What do y'all think on this one? They certainly share a side. So they have to be adjacent. That's inevitable. Do they form a line though? On the side they don't share? No. So they're just adjacent. And then 6 and 8. So 6 is this whole big angle. And 8 is this one. Well, again, what do y'all think? Yeah, they're certainly adjacent. Does their sides that they don't share, do they form a line? Yep, right here. That makes a line. So it's adjacent and a linear pair. Okay, so there's that one. Now let's look at our next type of angle pair. So we're going to talk about complementary and supplementary angles. Complementary angles, see if I can fit this all in here. Complementary angles. Got it. Are two angles whose measures add to equal 90 degrees. So if you add the two parts together, you'll get 90. Now, if we look at these pictures here of angles A, B, and C, what two can we add together to get 90? Well, C's out of there. It's over 90 by itself. So that leaves us with angle A and angle B. Notice they don't have to be touching to be complementary. They just have to add to be 90. The next one. So we got our complementary angles. Now let's look at supplementary angles. Those are two angles whose measures add to equal 180 degrees. So we're for sure going to have angle C this time. But what would our other one be? So to figure that one out, let's come over here to the side and say 180 minus 127 to see how much room we're left with. So that's going to be a 3, looks like 53. So we have an angle that's 53 degrees. That's angle A. So angles A and C are supplementary. The way you can remember supplementary and complementary, if you have whether you have a boyfriend or a girlfriend, it's always right to complement each other. Right is 90. Complement is 90. Think of it that way. It's always right to complement each other. Okay, so let's look at this example. First, they just ask us to find the measure of the following. So the complement, since we're dealing with complement, what do they have to add to? 90 of angle M. So there's our M. We got to figure out how much is left. So we're going to do 90 minus 26.8. And that'll give us what? Good. 63.2 degrees. Now it asks for the supplement of angle M. Supplementary is 180. So we're going to have 180 minus angle M again, so 26.8. And that's going to equal 153.2 degrees. And now supplement of angle F. So supplement is what? 180. So we're going to say 180 minus, we're dealing with angle F now. So 116.5, which gives us 63.5 degrees. Okay, the next part, it says angles DEF and FEG are complementary. What's it mean to be complementary? They add to equal 90. That tells us right there what we're going to need to do with them. So it says DEF is 3x minus 4. FEG is 5x plus 6. And together, they add to equal 90. So that gives us our equation. 3x minus 4 plus 5x plus 6 equals 90. Find x. So they're telling us just to find x, which we were going to do anyways. So we have to do anyways. So we need to combine our x's here. So I've got 3x plus 5x. 3 plus 5 is 8x. And then we need to combine our numbers. Negative 4 plus 6 is a plus 2, and that's all equal to 90. Subtract your 2 from both sides. You get 8x equals 88. I'm fresh out of the room, so I'm going to rewrite this up here. Divide by 8, and we get x equals 11. Now, what did they ask us to find? X. So are we done? I'd say so. We're done. So that's the front of our notes. Now let's flip over to the back. It tells us that angle DEF and FEG are supplementary. What does supplementary mean? They add to equal 180. It says DEF is 9x plus 1. FEG is 8x plus 9. So let's set up our equation. We're going to have 9x plus 1 plus 8x plus 9 equals 180. Now we've got our terms to combine. 9x plus 8x, 17x, and then our plus 1 plus 9, so we have plus 10 equals 180. Okay, so subtract 10. You have 17x equals 170. Divide by 17, and you get x equals 170 divided by 17 is 10. Now, did it ask you to just find FEG? To just find x? No, it asked you to find the measure of angle FEG. So we've got to take this 10 and plug it in up here. And if you've had me before or you haven't, what's my favorite thing to say when it comes time to plug in? You've got to plug it in, plug it in. If you don't get that little singing reference, look up the Glade plug-in commercial. Probably like from 2004. But look up the Glade plugins commercial. That's where they always sing it. You just got to plug it in, plug it in. So you'll hear me say that from now on. Just so you know. Okay, so the measure of angle FEG is equal to 8 times, what's our x? 10 plus 9. 8 times 10 is 80 plus 9, 89 degrees. There's our answer. Okay. So now we have the next set of examples. We're given the picture in A. What does this make right here? A line, and a line is how many degrees? 180 degrees. And on all these pictures, they just tell us to find the value of x. So we're just finding x. How can I get x? I've got to add these and set them equal to 180. So 3x plus 8 plus x plus 8 equals 180. Now let's combine like terms. I have 3x and I have x. That's going to give me 4x. I've got plus 8 and plus 8. And give me 16 was 180. Let's subtract 16 to the other side. I'm going to have 4x equals, let's see. Minus 1, 6. 164. So 4x equals 164. Divide by 4. And you get x equals, let's see, 4. 4 divided by 4 is 1. So you should get x equals 41. And they just ask us to find x. We're not having to find any angles. That's what the main directions say. Find x. Okay. Next one. Moving on along. So they give us two sets of complementary angles here. We have one set on the left, one set on the right. Since they're both complementary sets, they both add to 90, and one pair of angles is congruent. Remember, that's what these little marks mean. They mean congruent. So that means these two have to be congruent. And if they're congruent, what's that mean? They're the same. So if they're the same, how can I get x? Oh, you're telling me I can set them equal to each other. I think you're right. So now let's solve for x. Subtract 4x. 5x minus 4x is just 1x. Minus 11 equals 3. Okay. Now let's add 11 to both sides. We're going to get x equals 14. And again, I just said find x at the very beginning, so we're done with that one. Now for the last one on this group of problems, so it's not the last one total, but just for this group of 3 problems, what kind of angle is this up here? This whole thing is a 90-degree angle. So how could I figure out what x is? That's right, I could do part plus part equals whole. There's a part, there's a part, there's our whole, that 90. So we're gonna have 16x plus 5 plus 4x minus 5 equals 90. Combine your like terms. 16 plus 4 is going to be 20 and our x. Then we're going to have plus 5 and minus 5. Yeah, those cancel out. So we don't have to write anything. It's 0 equals 90. Divide by 20 on both sides. You'll get x equals 9 over 2 is your simplified fraction. But if you wanted to put it as a decimal, you could. It'd be 4.5. There's our answer for that one. The last piece of new information for this unit. Vertical angles. Vertical angles are 2 congruent angles formed by 2 intersecting lines. So if we look at this picture, they're the angles that look the same. So like 1 and 3. They're opposite from each other. So angles 1 and 3 are vertical angles. Which also means that angles 2 and 4. Oh, come on. As are angles 2 and angles 4. So they're just basically they're opposite from each other, and if they're opposite from each other, they're equal to each other. So now they want us to come in on this next example and name 2 pairs of vertical angles. So just to help y'all pick, I'm going to start with angle 1 right here. Which one looks like it's opposite of angle 1? Yeah, angle 4. So there's one pair. So angle 1 and angle 4. Now let's look at a different pair. I think I'm going to go over here with 6. Which one's directly across from 6? 3. So 3 and 6 is our other pair. And this next one, it only says 2 pairs, so we could stop. But remember that thing I said the other day? I'm kind of an overachiever. So let's go in and write the 3rd pair because we can already see it. angle 2, and angle 5. I mean, it's already there. Let's just write it. Okay. So now we have to solve for x. What do I know about vertical angles? They're congruent, and if they're congruent, that also means they're what? Equal. So to solve for x, I just have to set these two equal to each other. I'm going to have 6x minus 11 equals 4x plus 15. And now I just start solving. So I'm going to move my 4x over. Six minus 4 is 2 with my x. Minus 11 equals 15. Add 11 on both sides. I'll get 2x equals 15 plus 11 is 26. Divided by 2. And I'm going to get x equals 13. That's all they ask us to find is x. So we're done with our notes. So that's the notes for Unit 1, Day 6. Stay tuned for the guided practice.